Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can use MikroC for PIC's LCD library to interface an LCD with a PIC microcontroller, and then I will demonstrate this to you on the Proteus, and I will also run the simulation and the programming will be done on the MikroC for PIC. So let's get started. So guys, first of all, we go to the Proteus to make a circuit. So let me zoom it in for you. Okay, go to the schematic tab. I'm using Proteus 8, and in the schematic tab, click on right click, place component from library, write down PIC 16F877A. This is the microcontroller we're gonna need here. Place it anywhere on the screen. Now guys, place the LCD. This LCD library is for this LM016 LCD that is easily available in the market. LM016. This is the LCD. You can have 16x2, 16x4, etc. Doesn't matter, like this. Now guys, let's get to the MikroC and let's take a look at the library. So this is the MikroC for PIC. Make a new project first. Click on File, New Project. It will lead you to this new project wizard. Click on Next. Write the name of the project. LCD Library MikroC Learning Microcontroller Tutorial. That is the name of the project I wrote. PIC 16F877A is the one I'm using. 20 MHz is the crystal I'm gonna use. And then I click on Next and Finish. Now guys, before you do anything, first of all, press Ctrl S to save your project, like this. Now guys, go to the right, expand the library manager, micro E libraries, then expand the system libraries. Here look for this LCD. You expand this, LCD library is now selected. Now guys, in the LCD library you can see that it says LCD char, LCD char CP, LCD CMD, LCD INIT, LCD out, LCD out CP. Now guys, this CP means the cursor point, that whenever you will write something, it will write next to the cursor point. And this LCD CMD command is here for sending the commands. Like LCD CMD clear screen, it will clear the screen. Now LCD CMD, LCD start first row, that it will start writing from the first row. Similarly, second row, third row, fourth row, LCD clear, return home, it will return the cursor to the original position. Cursor off, if you don't want to show the cursor on the screen, you can use this command. And now LCD underline on, it will underline the cursor. Now cursor blink, cursor will keep on blinking if you use this command. Cursor will move to the left, cursor will move to the right. LCD will turn the display on. Like you are using the display or you want to save the battery, you will use this command to turn the LCD off, and this will turn on the LCD. LCD shift left and shift right. These are the commands you can write using this command. And other than this, you have there LCD out. This is the most useful command. LCD out command will out whatever you want to write. You can say whatever you want to write the text. Let me show you. This is how it's written. LCD out. This is the row. This is the column. Start writing from the first row, first column. What it should write? Hello. Whatever is inside these inverted commas will be written on the screen like this. So this is one of the most useful commands. So we do a simple stuff. We will use the LCD INIT command. We will use the LCD clear command. We will remove the cursor and then we will display the hello on the screen. In this tutorial, we are not going to use this char CP and LCD out CP command. I will show you in another tutorial. So first of all, we initialize the LCD. To initialize the LCD, you double click on the LCD INIT command. Then in the global variable, it says that whatever your LCD works in two modes, 4-bit and 8-bit mode. If you are using the 4-bit mode, then only these are needed. And in the 8-bit mode, you will need also D0, D1, D2, D3 as well. So let's initialize the LCD. So these commands in the example, you copy them till here. And you have to place them above the void main. These commands will initialize the pins you are going to use for your LCD. Now let's get to the Proteus. Let's select the pins we're going to need here. So first of all guys, As you can see, this 16 cross 2 LCD, 16 pin LCD, it also comes in 16 cross 4 as well. First of all, you will connect pin number 1 and 5, common them, and then go to these terminals and select a ground. Place the ground at the bottom and you send it to the common ground like this. Now guys, here this pin is the power pin. You go to the right and take out the power source and you give this pin VDD pin number 2 of the LCD power. Now this LCD is a contrast adjustment pin. So you go to the components again and bring a variable resistor of 10K value like this. Here look for the resistor. This one is a 10K. Click and place it wherever you prefer like this. Give it 5 volt from one end and the other end will go to the ground, and this center pin is an adjustable pin. Send it to the VEE pin of your LCD like this. Now these are the basic connections which are done. They will remain the same. Now these pins RS, E, D0 to D7 pin, these are your pins to be sent to whichever digital input output pin of the PIC is available to you in your project. You can use them. So here I am going to use for pin RS, I am going to use a pin number D0. For EN, I am going to use a pin number D1. For data pin 7, I am going to use pin number D2 like this. For data pin 6, I use the pin D3 like this. For data pin 5, I use D4, and for data pin 4, I am going to use the pin number D5 like this. So guys, in this way our LCD is connected. It's simple as that. It is connected in the 4-bit mode, and in the 4-bit mode you do not need D0, D1, D2 and D3. If you use LCD in the 8-bit mode, then you need these 4 pins as well, but in our case we don't need them. So guys, now that is what we want to do in the, now go back to the MikroC. Now when initializing, here he asks that in the sbit LCD RS at which pin, and in our case it is D0. Enable, now the second is the enable pin. Enable pin is at D1. If you use other pin for this, no issue, simply change the parameter here, like you had used C1 for the enable, then simply write the C1. For the D7 we are using D2 like this. For D6 we have D3. For D5 we have D4, and for the D4 we have D5. Let's go to the Proteus and recheck. See that we have D0 for RS, D1 for enable, and then we have D2 for D7. Now let's go back to the MikroC. See that D0 for RS, EN, D1, D2, D7, D3, D4 and D5. Similarly, for the pin directions as well, do the same. You have to just repeat this configuration here as well. For RS, we have D0. That was the pin setting, and this is the pin direction. For enable, we have D1, D2, D3 for D6. Do the same as above. D4 and finally D5. In this way, your LCD pins get initialized. You don't have to now separately give like trace D dot F0 equals to 0 or 1. This is done on auto. That is the beauty of this library. Once you have done this, now you can easily use LCD's other commands as well. Now guys, we initialize the LCD. For this, go to the LCD INIT command again in the library. Here below this, you can see that this is the command. Just copy it, LCD INIT. Now this will auto initialize all of these pins, and your LCD is initialized at these selected pins like this. Now guys, give some initialization delay, 100. Okay. Now guys, what we do is that we write something on the LCD, like we display hello. So go to this LCD out command, LCD out, write hello. Hello. Start writing from first row, first column and display hello. So we build this code and we go to the Proteus and see what happens. Okay, we had built the code. Now in the Proteus we check the crystal we are going to use is 20, like this, and go to the folder where you had generated the hex file. This is the hex file. I click OK, then I run the code. Now see guys, it is showing hello and there is a cursor blinking as well. So we are using the cursor here. See, I remove this cursor, I don't want this cursor. So we go back. So here what I do is that I go to the right LCD CMD command. You copy this in the example, you copy it above the display command and then here remove what is inside it and go back to the LCD CMD, and in the table below you have various commands. Look for this command LCD turn cursor off. You copy this green part, go back and paste it inside the brackets like this. This will turn off the cursor. Now we build this code and we go to the Proteus and see again what happens. Now see that the cursor is gone. Now I want to display it on the second row as well. So I go back and I copy this LCD out and I write here world, hello world, and start writing from the second row first column. You have 16 columns, so I write from the second row and start writing from the first column on the second row. Now I go back, I click on run. See, this is simple as that. Now you can display variables as well. Like I go back to the MikroC and I make a variable here. I write like char alpha 10 equals to, okay, I write learn. Okay, learn. Now learn has 1, 2, 3, 4 and 5 characters. So I remove this or I do is that I copy this and I display it on the 2, 1. It has world has 1, 2, 3, 4, 5 characters. So I start writing from the 7th, like we have maximum of 16 columns. Start writing from the 7th column. What it should write? Alpha. Whatever is in this will be written on the screen. You can do this as well. In this way you display sensors and other values. Now that's very simple. Let's see what happens. Let's go to the Proteus. See, hello world. Now it displays a learn as well. So guys, it is simple as that. These three commands, LCD initialize, LCD CMD command for clearing the screen and that complete table, and LCD out command. These are enough for you to use this LCD. You can use the CP command and other command, but they are not of much use. These commands are very useful. If you know how to use this command, you can easily use this LCD using a PIC microcontroller, and it is even easier than using this LCD with the Arduino library as well. This library is way more easier than Arduino as well. So I hope you guys learned something from this video. So guys, thank you very much for your time and have a nice day.